we are talking about hacking MySQL for big data and how to use your database to basically work with bigger data sets. Right, so what we already covered in the beginning was what is big data and why you should choose MySQL when working with big data. What we will also cover is why would you choose MySQL for big data and things you should know. Right, so as I said, I'm a security and database guy. I run a data breach search engine at databasedive.com. I run a YouTube channel, and I also wrote a book for A-Press titled Hacking MySQL. I'm also a speaker at multiple conferences, including this one. Right, so we already covered a little bit of big data, but as I said, each developer understands big data differently, right? So for some, big data is 100 million rows, for some it is 1 billion rows and above. But for our use case, where, as I said, we're talking about anything with more or equal to 100 million rows, and you should also consider your use case, as I said above, as I said earlier. Now, why MySQL? I started talking about this, and then I had to change to Google Drive, so I'll repeat it again. MySQL is not only MySQL. MySQL has three flavors. Primarily, it's MySQL Server, Percona Server, and also MariaDB. Each of those database management systems have their own unique sets and capabilities, including storage engines. For example, XtraDB will also only be available on Percona Server generally. InnoDB will be available on all three, and TokuDB will be available on Percona Server and MariaDB most likely. MySQL, as I said, also supports ACID, which means that basically if your electricity goes out, your data doesn't get corrupt. And basically usage of MySQL or no usage of MySQL, it depends on your use case. Right, so here's where we got stuck. So in essence, MySQL has a couple of parts. It consists of the file system, storage engines. It consists of a parser, the optimizer, and the SQL interface. It has hashes and buffers, which can either be global or engine specific. And it also has a connection pool, and it also has connectors, which means the ways you connect to your database. You can connect through C, through Python, through PHP, or through other measures. The reason why it is so important is because the structure of the database is often the first thing that you will get stuck with when dealing with bigger data sets. The thing you have to understand is that, for example, MySQL's primary storage engine, that is InnoDB, it stores all of its data in one file, that is IBData1. IBData1 stores data, indexes, and all of the other metadata. Newer versions of MySQL, mind you, split the files that are in your database and the data that is in the file, the IBData1 file, because in older versions of MySQL, it wasn't possible to basically deduct the if you would drop your table in your database, your data would still reside in the IBData1 file, and the only way for you to get rid of the IBData1 file would be to delete it. But if you deleted it, all of your data would be gone. So newer versions of MySQL overcome this problem. But anyway, there's a couple of more things that you should understand when dealing with bigger data sets. And the primary thing is your use case. What I show here, for those who are not really aware of this, it's my data breach search engine available at breachdirectory.com. And I'm using MariaDB to facilitate searches through data using the search engine. And if you input your email, username, IP address, or a domain, you can basically get a message whether your data is at risk or not, or whether you should change your passwords or not, basically. Basically, it tells you whether have you been hacked or not. So I highly recommend you using this. I have a lot of well-known people, universities, companies, and so on using this. So it is a reputable service, and I'm very glad I made it. Right. So when dealing with bigger data sets, most likely you will need to run a couple of queries through your database, right? So the fact that you need to run queries through bigger data sets most likely comes through a need to loop through something and then run some kinds of queries and then return results to a user, right? So what you see now is essentially a loop that loops through all of the tables in the database, puts the table name into a variable name, and then basically uses a prepared statement to loop through all of the available tables where a specific search type is equal to a search query provided by the user. The important thing here is that the search query and the rest of the query are separated, so there's no SQL injection, which is a primary objective of prepared statements. And then we grab it and put everything into a results query, as you can see here, if it's visible. And then we do whatever else we want to do. The most likely scenario will be something like this. But for this scenario to be true, you would have to have the first thing, data. Your data will be of some class. So if you're dealing with data breaches, it will be most likely more sensitive data. If you're dealing with a, I don't know, banana factory, most likely you're storing types of bananas or something there, right? Regardless of the data class, you will have some sort of data and you will have a lot of the data, right? Next thing you're going to have is a database management system. And another thing is a VPS that you store the data in. And you're most likely going to upgrade to a dedicated server when the time comes, because your data will be bigger than usual, most likely, and VPS won't be able to deal with it anymore. That works when you have more than 5-6 billion records, like something around that range. If you're dealing with such big data sets, you're inevitably gonna need a backup plan as well. So a backup plan to backup big data sets is also a very important option, and we're going to talk about it in a second. And you're going to also need luck. Depending on what kind of services you run, you are going to meet some people that are probably not having your best interests in mind, or just having issues with the hosting provider that you need to know how to fix and stuff like that. So here we come to your server. The slides right here are a little bit off since it's a Google slide, but it's okay. Here we come to your server, right? So for your server, you would need to optimize a couple of parameters to optimize MariaDB, MySQL, or Percona server. These parameters would most likely be InnoDB buffer pool size, InnoDB log file size, flushing log at transaction commit, and a couple of other parameters if necessary. These can be found at the documentation. What these parameters do is the buffer pool size found here, it makes your insert queries faster when you insert a lot of big data, right? Because it makes MySQL be able to use more operating memory when inserting data, which in turn makes your insert queries faster. Now you don't need to have 64 gigabytes of RAM on a server to make your database and application work, but it's recommended that you set this parameter to at least 60% of available memory on your server. Next, we have the log files. The log files are necessary to restore your database from a crash. When restoring a database from a crash, the database reads through log files, and basically the bigger they are, the faster your database will get restored from a crash. So it's essentially recommended to put a quarter of the buffer pool value that you put here into the log file size value. The flush log at transaction commit variable controls the balance between ACID and faster query insert speeds, right? ACID, it means that basically your database remains integral. Your data remains integral despite any errors, power outages, or whatever, but this can be turned off. It can be turned off by setting the value of this variable by 0 or 2 instead of the default value 1, which makes your database ACID compliant. These three parameters are most likely everything you will need to optimize when working with InnoDB. These are the most important ones. Some of the other parameters exist, but these can be found in the documentation because there are so many, I will not be able to cover all of them. Aside from parameters, you will also need to deal with indexes in your database, right? Indexes are a very important thing in databases because indexes make select queries faster, which means that if the primary use case of your application is a read use case, which means that if the primary use case is a search engine or something like that, you will probably gonna need to make use of indexing or partitioning or both. We're gonna cover this in a second. Right, so how do you decide when and what to index? This is the most important question probably that all of you are gonna have. And the answers to this are very, very simple. You basically index select operations on bigger data sets. You index columns that you run select operations on, because columns are the things that are going to be used by a query. And that answers the second question as well. You need to index necessary columns by the time you're running select operations on bigger data sets. Bigger data sets with indexes will make select queries faster at the expense of making updates, deletes, and inserts slower, because data has to be inserted, updated, or deleted together with the index as well. And this is why the index takes up space on the disk, because it's a separate data structure as well. Right, so Google Slides doesn't show the structure of the indexes here, but what this slide is supposed to depict is basically here you'd have your SQL query, and here your database would essentially consider your index, what kind of the index it has to use, and whether it is a covering index or not. Covering index means that your database can read data straight from the index instead of reading the data from the disk, instead of accessing the disk. And here, basically, it denotes a couple of steps your database takes that makes it decide what index to use, what index is best to use. Because if your query is selecting 2 columns or all columns after the where clause, your database has to make a couple of decisions, which are depicted here, to choose a proper index. Now, Google Slides unfortunately doesn't show everything that is supposed to be depicted here, but think of this as your database deciding what kind of index it should use. The kind of index your database should use is can be accessed by running an explain query in front of any of your database queries. So if you run select queries, you just put explain in front of the select query, and your database will explain all of those steps that it takes to reach to choose the perfect index it should use. If it does not choose the index that you want to use, you would have to modify the query. The rules here are very simple. Your database will choose the index based on what clauses, what columns are selected after the where clause. So if your query is select ID from users where email equals something, the index that will be considered for use will be on the email column. So this is how you should think about that. Indexes actually deserve a book of their own, so I'm not going to get too much in depth about them, but this is how they are. Next thing that you should keep in mind is your backups and your backup internals. The way you probably backup data by now is by taking logical backups like this. What this depicts is probably, letters are very small, but what this depicts is creation of table, which with the structure of table as it is, and then inserting the data into the table using insert statements, as you can probably a little bit see right here. So what this does is basically, this is called a logical backup. And why is this called a logical backup? Is because your database backs up logical SQL statements, that is SQL statements that recreate the data, which is what is being done here. But if you have a lot of data, you would probably think or see that these types of queries are a little bit slow. And these types of queries are a little bit slow because each insert query that you see here, this is one insert query because it's in bulk, but it still be rather slow because you have a lot of data to insert. As you can see, you have multiple rows. And each of those rows that are inserted, each insert statement comes with a little bit of overhead. So this is what each insert statement does. So it has to start, it has to check for permissions, it has to open tables, initialize, update data, end the query, close tables, free items, and clean up. And you can understand if you have data with, let's say, 1 billion rows, that means that these steps that you see here, these steps that take milliseconds right now to insert one row, it will be multiplied by 1 billion. And this is why people wait weeks for queries to complete, because each query takes this duration right here of time to complete. And if you have 1 million or 100 million or 1 billion rows to add, it naturally, your database naturally multiplies this duration by the rows you need to add. This is a very simple explanation. How do you overcome this? People overcome this essentially by importing or using the backups without overhead. And backups without overhead, it means that essentially they back up raw data. So instead of, as you can see, backing up statements that recreate data, as you can see, create table, insert into blah, 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 they just back up raw data sets, which means that they have data from one column, second column, third column, fourth column, and whatever. And it's usually separated by some kind of character, as you can see here. Sometimes it's a dot, sometimes it's a comma, sometimes it's a different character, as you can see here, and all kinds of data can be separated like this. The reason why you back up data like this is because importing raw data, it usually comes with thousands of times less overhead than importing logical backups like these. Now, how do you come up with data like this, and how do you import data like this? So this is where it comes for you to, I need to take backups like this. So essentially, you would have a loop that runs queries like this one that you see on the screen. It means select the data you need from some table into an out file called something file name, and then a bunch of options. What this does, basically, it tells the database that it should select all data from some table, where basically you specify whatever clauses you need, into a file called the file that you specify here. And the fields terminated by something makes it so your fields are terminated by some character, as you can see here. Like this character, this right now. So there's a bunch of other options that you can use. You can ignore lines, you can specify lines starting by something, or you can basically only select specific columns. These kinds of backups can be restored like this by specifying load data in file and then your file location, basically, into table, that your table name. And this is basically everything you need to do. These kinds of queries, these two queries that you saw right here, one of them will actually select data from your table into a file, and the second one will actually load the data inside of a file into a database without any overhead, because they will not come with logical statements that the database has to repeat. It will only come with raw data like this. Not logical statements like these, but raw data like this. And this means by the time your database completes, inserts like 1,000 queries, 1,000 rows with queries like this, you would insert, let's say, 10 million queries like this. And you can obviously see by the time you're about to use such queries, load the data in file, it will be sometimes even thousands of times faster than usual insert statements, because again, it doesn't have any overhead. I suggest you to refer to the documentation if you're going to use this, because it probably seems a little bit scary by the way it's written here, but these are the pretty much all of the available options that you can use. And aside from backups, you also need to adhere to some sort of bugs in the future, right? It's likely that you will come across bug or two, because MySQL is such a database management system where in some areas something is broken. So for example, here you can see two queries. The text is a little bit broken because it's Google Slides, but you can see the main idea anyway. So the first query is like this: select all from table where match column against demo, where demo is the user's input. And the second query is select all from table where match column against something that has an eta sign in Boolean mode. And in this case, the eta sign would crash the database if your database is running MySQL 5.7. The reason why this happens is because your query decides to take a different path when executing. Why this happens, why does it take a different path, no one can explain. This is a bug within MySQL. This is actually a real bug that I've uncovered with the assistance of Charles Bell, which has led the MySQL's replication team in the past. But this is how it works. You are likely to encounter such bugs if you work with bigger data sets or if you dig deeper into MySQL. So this is kind of everything I needed to share. I hope that this talk has been insightful, even though I had to repeat myself and kind of redo my talk a little bit. But I hope that you have enjoyed, and I'm now available.